Now we are going to learn about implicit data type conversions in the Mapstruct. So here we are going to focus on the implicit data type conversion and custom conversions. As part of the implicit data type conversions, string to string we already seen it, there is nothing new, but date of birth, which is a date type, salary, which is double type, will be converted to string. Before we look at the implicit data type conversions, in the %db object we have the ID, first name, last name, date of birth and salary, which are long, string, date and double data types. And the %tto we have the first name, last name, employee ID, date of birth, salary, age and service in years. So we have the string and integer. Here I took the primitive data type, but you are free to choose any of the data types. So let's check the mapper and its implementation. As part of its implementation, if we see it, if the date of birth is not null, it's using a simple date format to convert the date of birth into a string. And it's the same for salary as well. If the salary is not null, they are using string.value of to convert the double into a string. Let's run the unit test case to see the output. If we see the output, here we have the first name, last name, date of birth, salary, age and service in years. If we see the date is coming in a standard format, which is DD, YY, HH, For the data formation, Mapstruct supports the date and number formats. What I mean is, in our example, we got the date of birth as DD, YY, HH, Instead of it, I would like to see 01-Jan-1950. How we can convert that one. And along with that, for the salary, I don't want to show precisions of 5. Instead of it, I would like to see only last 2, and I would like to prefix with USD or INR, which is a currency code. So let's see how we can achieve these two using the existing Mapstruct feature, which is a formation. So let's go to our mapper. In the mapper, let's import mapping. Now what we need to do is, we need to define, first of all, we look at the date of birth. So target is date of birth. For that, we need to give the source. And the source is also date of birth. Now, we need to provide the formations. Let's see what are the formats that are supported. We have the date format and number format. So let's choose the date format. And as I mentioned, I would like to give DD -YY. And the next mapping, as we discussed, which is a salary. So salary, and the source also salary. Now we are going to choose number format. In the number format, we need to give currency code. Let's say INR and hash represents the digit. So in this format, and I need 2 precisions. That's the reason I give 2. So in our case, we have the total 5 precisions, which will be rounded off to 2 precisions. Let's save the file and look at the implementation. So in the implementation, for the simple date format, the date format whatever we have provided has been passed as a constructor parameter. And it's the same for the decimal also. Even the decimal format, it takes it. And if we provide any wrong formations, then the compilation would fail. Implementation file will not be generated, which means generation will not happen. Let's run the test case and see. Now if we see it, date of birth is coming 01 Jan 1950 as we expected, and even the salary came as 96. Ours is 95623. That's what we have provided as a provision, and provision is rounded to 2 digits, which is 96 in this case. Now look at the custom conversions. So for example, as part of the DTO, we have age. So we need to calculate the age. How we can do that one? So it's a simple and straightforward. In the mapper, we can write our own code. We can write our own custom implementations. Default, as it's a interface, I'm providing the default method and I'm returning integer and I'm writing simply name as test and I'm providing date of birth. So in this case, date and TOP and just simply return 0 just for testing purposes. Let's create one. So target, I'm taking, as we discussed, I'm taking the age and source as date of birth. I'm not providing any more details. And if we see the implementation, for the age, the method has been called. The date of birth would say date and a return type matching method signature. Integer as a return and date as an input. Let's change and age as, let's say, 18, just for testing purposes. And we have another one called service in years. Target service in years. And it is also exactly the same signature, which takes a date and returns a number, which expects a number. So let's see what happens. So in this case, for the age and for service, it called the same one, which is not correct. So let's try to provide another one. Let's, for our naming reference, say map age. Let's write another method, say map service in years and say service is 20. And if I see, now we are getting a compilation error because there are two signatures, two method signatures that are matching the requirement. So here it says ambiguous. So how are you going to resolve this one? For these cases, Mapstruct provides an annotation called named, and you need to provide what exactly it does. In this case, let's use the same name. So now the compilation has gone. In the implementation, if we see it, in both the places it used the map age because that's the only matching signature, and another one is named. Named methods will not be called unless we define them. How are you going to define them? We are going to use qualified by name. In this one, you provide the exact mapping name. So now if we see the implementation, for the age, map age is called, and for the service in years, map service in years is called. So just to avoid all the confusions, I recommend you to create named parameters for all the methods that you create and call them appropriately. With this way, you will not run into any of the error prone code. So for the set age, we are calling the map age, and for the service in years, map service in years method has been called. So let's run the unit test case and see what exactly it prints. We see it, age is 18, service in years 20 as we expected. Of course, the logic is not accurate. We just returned some random number. Now, for example, if we are using the same kind of functionality at several places also, then how are you going to do it? Let's say in our case, we have similar functionality across 3 or 4 mappers or more than that. In that case, how can we do it? So what we can do is we can move these methods into a class and we can use that class as a reference. Let's cut it and create a new class. Let's say date operations. Let's say, date operations. Paste the code. Here the default methods are not accepted because it's a class. So let's save it. Now what we need to import this class. How are you going to import it? How are we going to notify the mapper framework that this is the class which contains the named annotations for the respective mappings? So for that we need to use uses, and it takes an array. So we need to provide data operations class. And let's see the implementation. Now the implementation, it created a instance variable called data operations, and it uses the data operations to set the age and service in years. So this is one way to do it. So I would recommend you to separate the name once if those has the common logic. Otherwise, I would recommend you to keep it in the same person mapper or the respective mapper interface itself. Let's make another change. Do we need to do all the time by qualified by name? No, not required. We can use the qualified annotation as well. Qualified, and which takes the annotation. Let's create an annotation. For the service in years, we are going to use the annotation based mapping. So how are you going to do it? Now let's go to the data operations and refactor the name as a data operation as age operations. And I'm going to create service operations. From the service operations, you remove it. And here I would like to add annotation called service in years. So let's create an annotation. We need to add the target. So let's add the target, and the target is on the method. We are going to add this one on the method. Generally, we add the retention also. So anyway, we are going to use an annotation as class because we're going to apply in the class. And is this enough? No, we need to notify that this annotation is a qualifier also. So which is a Mapstruct. Let's go to the person mapper. In the person mapper, we are going to use this annotation qualified by. This also takes annotation array, but in our case we have only one annotation. Let's keep straight frame. So service in years class, save it. So here it says that it can't identify because we need to import the class. We need to use the class. So the class is service operations dot class. Now save it. Let's look at the implementation. As we expected, age operations and service operations object has been created and used appropriately. For the service operations, it uses service map services, and in case of the age operations, it uses the map age. Let's run the test case. Yes, it worked perfectly fine. Set equals. So DTO.get date of birth, which we are expecting is DD YY. So 01 John 1950. And the next, we're going to expect the salary. DTO.get salary. And here I'm expecting INR 100 and rounded off to 2 digits, which is in that case 96. And DTO.get age. So we gave it as some random number. So what we can say is not equals to, because integer is a primitive data type and the default value is 0. So let's use asset not equals DTO.get age not equals to 0. Asset not equals DTO.get service in years not equal to 0. Now let's rerun the test case just to ensure all our assertions are correct. Yes, assertions are correct. You might get a doubt. Do we need to go with this logic? In this case, yes, because we used as a primitive data type intentionally, so it can be assigned to 0. So I can do the validations because I'm using some random one. I'm returning 18 here. I'm not actually finding the age from here. So that's the reason I kept it as not equals to. That's all for now. Thank you.